Okay, this was only repeating, but you can do maybe more complex tasks inside the repeaters, inside the nodes. And this is the classical example of network coding. Network coding assumes that the signals A and B have to be transmitted to the bottom nodes. So, and they have three possible paths. And if ever the middle path is transmitting either A or B, one of the two bottom nodes will not be able to recover one of the signals. Assume that the middle path is transmitting A, okay? Node on the right will receive A and B, but the node on the left will receive only A. But if you just think a very simple example, that's the butterfly scheme, which is very frequently explained in this kind of context. If you allow the node which is receiving A and B, oh my God, to transmit a combination of both signals, both nodes at bottom will receive both signals. So that's physical layer network coding. That's an improved situation. Cooperative diversity, meaning maybe also a node can amplify the signal which is received, meaning 1 is willing to speak to 0, and 2 is listening to what 1 is saying and receive it, amplify it, send it again. That's at the physical layer, because that's an amplification of the signal. You can also have source diversity, meaning that some source coders work with descriptions of the signals. The description is, okay, if you have one description, you get a rough copy of the signal. If you get two descriptions, it's a better signal, but everything, you can understand everything. Meaning that's also cooperation. If you have descriptions all over the place, maybe it will be more efficient than the classical situation. Okay, the rationale of the project. I'm not going to really describing the project. All these cooperation techniques are obviously not fully compatible, okay? They are not as efficient as the other ones in all circumstances, and sometimes are not applicable without a drastic change in the structure of the networks. But if you want to work on that, we are not able to work on a specific knowledge. We have to work with the other knowledge so that we can solve the problems. Okay, so we built a project which was so large at the end that we broke it into 5 work packages. And I will go through the work packages now, explaining you why we stated the problem that way, and maybe explaining how we would like to have this project evolve. Okay, so cooperation at physical layer. So cooperation could happen at many layers. At physical layer, okay. If you remember what I explained about network coding, what makes everything work is the linear combination. Whatever linear combination you can obtain the same kind of result. But a mobile wireless channel is doing linear combination, because when you receive 2 signals, you receive a linear combination of 2 signals. If ever you know the coefficients of the combination, you can do a similar thing as I explained about network coding. This is named physical layer network coding. So it seems to be kind of central, so you can compare it with the mechanism which is relaying at physical layer, with a mechanism which is network coding at higher layers, and in that way we hope that we will understand how these kind of processes can work together and where this kind of process is the more interesting. Okay, so that's, and we have also a part on channel code design, because obviously in communication you always have to take channel code design into account. Another aspect is, okay, quite different. But if you are thinking that mobile can help the other ones, well, obviously it will depend on where these mobiles will be located. So the geometry of the network is of importance, meaning that, okay, if I want to speak to somebody at the far end of the room, and there is nobody in between, if I do not speak loud enough, nothing will happen. So if we want to study what is happening on average in many situations, we have to take into account the statistics of the location of the users, of the nodes. And this study can be undertaken with stochastic geometry, which brings a totally different point of view as what is classically used in digital communications, which is information theory. And in this work package, we are bringing together people working on stochastic geometry and information theory so that they can enrich each other's knowledge based on the other aspect. Obviously, also, a user maybe will not be willing to help the other ones because it costs battery to him. So we have to take into account that maybe there is an impact of the willingness of the users of doing the process, of belonging to the process. And we want to address the problem using game theory. Okay, since time is going fast. So we can also work on the source aspect, and already explain why it was important, because in some situations it can be very useful to have part of the signal here, part of the signal there, and whatever path is working, I can obtain something. So clearly it can be of real use, for example, for video on demand, for broadcasting, for many things like that. And also, if users are willing to help, obviously they can understand what they are transmitting if nothing is done to prevent them from doing so. Also, if you have a network which is a business running, maybe a computer, okay, somebody will be willing to make the network crash because to kill the way it is functioning. Meaning that, and so that we have to take these two aspects into account. This is security in wireless networks. Okay, so that the current status of the project is that out of these 5 work packages, which are being growing, 3 of them are currently funded by DIM call, and 2 of them, I'm still looking for funding for 2 of them, but I think we are in good shape. Each project is based on cooperative work. PhDs, postdocs will be co-advised by people coming from 2 different communities so that everybody will be able to learn outside of his current knowledge. We think that there are still missing work packages. And this one, we have 2 examples. The first one is robust routing. Okay, it's a crazy word for something very simple. If all of you are willing to help each possible communication, you will have a huge amount of interference. Everybody will be speaking, just like in the crowd. If everybody is trying to help to repeat what somebody is saying, nobody will understand anything. Okay? So that's exactly what will happen if everybody is trying to help everybody. It cannot work. But somebody will have to keep silent. If you want to help, you can do many things. You can do, as I explained, network coding. You can do relaying. You can do. So if we just decide here, each of you is maybe willing to help. So somebody has to decide, and it has to be done through a distributed process, what will be the role of each participant. Okay? So and this is similar to a routing algorithm. Many people will have to remain silent, and you will have to decide about a few paths. So, and about this increase of redundancy, of interference, hierarchy certainly will have to be reintroduced at some point. Okay, it's well known that manets, which is the general view of these non-supervised systems, do not scale an appropriate way, meaning that if you have too many users, it will not work. The system will be inefficient. So that at some point, we'll have to work locally and have somebody playing the role of a base station, but maybe not for receiving all communications, maybe only to coordinate the calls in some area. And this is certainly something which has been very little studied, even at a theoretical step. So as a conclusion, on time, the project has been to solve scientific problems. If you look at each and every project, it's basic science, long-term studies. But it has been built in such a way that it's likely that the results that we will obtain can be used in a reasonable amount of time. Okay, cross-layer, for those of you having heard about the domain, is the fancy word currently. What we will be doing here is more than cross-layering. Cross-layering is I am tuning a layer with respect to what is happening at other layers. We are willing to build an integrated understanding of the wireless systems. Okay, and I hope I convinced you, at least we are convinced, that none of these problems can be solved by working only on a single area, a single domain, and that only cooperation will be able to solve this cooperation problem. Okay, and that's it.
Thank you, Pierre. Are there any questions about this very interesting talk?
Yes, my question was about, I guess there are other teams worldwide working in on those topics.
Yep.
Could you elaborate on that?
Okay. I had to skip that. On one of the slides, I said we decided not to compete with the people working top level on the specific point worldwide. Okay? So what I think that our true impact will first be that we will bring together knowledge so that the layers and the knowledge can work together efficiently. If you think at number of proposals which have been made in the past years, some of them, if you do not do that, will never be used because it's not possible. They are forgetting too many things. So I think that our strong contribution will be to bring things together, and obviously, I hope that we will have also contributions on each topic. But, and I think we are in a good shape for doing that, because on some points, we are not in a bad shape. And we will also be able to attract, and I hope it will work, worldwide known researchers for 1 year sabbatical and so, and I think it's currently doing well.
Just a follow-up question. At some stage in your project, you will have to do some large-scale experimentations to test the different approaches. How do you plan to do that?
Okay. I do not know whether we will be forced to have large-scale experimentations. Our plan is to have results done on simulations, on small-scale samples, and that we will be able to convince people from industry that we can work together with them for large-scale experimentations.
Well, I have one question. I assume that if this work becomes an application, then some new standard will have to be introduced so that new mobile phones implement it. So I assume there is going to be some upward compatibility That is, an old phone will just talk with the station, while new phones will talk one with each other. But is it necessary to have just one worldwide standard for those cooperative schemes, or is it some possible compatibility between several? I mean, imagine, for instance, that in the United States you have one standard, and in Europe you have a different one, and then you have an American mobile coming to Europe. What's going to happen?
By the way, I don't know what will happen. Okay, if you just think at what is actually existing, if you have Wi-Fi, if somebody has a connection with Wi-Fi, he can share, using Wi-Fi, his connection with other people in the same room. But very few people are using that. And we are going to a situation where the networks will be more and more heterogeneous. So maybe you can have a standard, maybe on a given, okay, not now, but in a few years, for allowing cooperation, for example, using Wi-Fi, using a specific thing which maybe will be designed at that time, and that the connection between these systems will be allowed, and in some way. Okay, so I don't know whether. Okay, I think anyway standards are very useful, but okay, it's a very complex question. If you think about game theory is studying what each participant would do without any constraint. This is without any standard, okay? And a few things can work that way. But if you have a standard, you can constrain people to act a very specific way. And this kind of process is just in between. We want to have a few constraints so that things are feasible, but not many constraints so that a lot of freedom is left. I don't know whether I answered. Okay.
Okay, thank you. Are there other questions? No? So thank you, Pierre.
Thank you.